Hello, and a very warm welcome to Cognito Key. Today, we're going to pull back the curtain and peek into the secret language of computers. We're going to explore the tiny, microscopic brains that make every single decision inside your phone, your laptop, pretty much everything digital. I mean, have you ever really thought about it? How does your phone know anything? How does it recognize your face? Or how does a calculator get the right answer every single time? Well, I can tell you, it's not magic. It's logic. Millions of simple yes or no decisions happening faster than you can even blink. So, here's our game plan for today. We'll start with how computers actually think. Then we'll learn their super simple language. After that, we'll meet the three essential players, the OR, and not gates. And finally, we'll see how they all come together to build the incredible digital world we live in. Sound good? Let's get started. Okay, so to understand how a computer thinks, you have to zoom way in. I mean, past the apps, past all the code, right down to the most fundamental, the most elemental building block of digital intelligence. And this is it. It's called a logic gate. At its heart, it's just a tiny electronic circuit with one very important job: to make a decision. You can think of it like the smallest possible brain cell in any digital device. Billions of these, all working together, are what power every single thing your device does. So if these gates are the brain cells making all the decisions, what language are they speaking? Well, it turns out it's the simplest language in the entire universe: binary. See, in a computer's world, everything boils down to just two things. A 1 means there's a high voltage, which is like saying on or yes, and a 0 means low voltage, so off or no. That's it. That is the entire vocabulary. Every complex thing, from editing a photo to navigating with GPS, is just solved by asking and answering billions of these simple yes or no questions. All right, let's meet our first decision maker, the OR gate. You can think of this one as the really agreeable, super inclusive member of the group. The rule for the OR gate is beautifully simple. It just looks at all its inputs, and if any one of them is a 1, a yes, then its output will also be a 1. Basically, any yes is good enough for a yes. This chart here, the truth table, maps out every single possibility. And as you can see, the only way to get a no, or a 0, is if both inputs are no. If input A is a yes, or input B is a yes, or even if they're both yes, the OR gate happily gives a yes as its output. And this is why, in the world of computer science, the OR gate is seen as performing addition. Its expression is written as A plus B equals Z. Now, if this is our easygoing gate, let's go meet its much stricter sibling. Next up is the AND gate. And if the OR gate was easygoing, the AND gate is, well, it's the strict one. It's very demanding and has much, much higher standards. The AND gate's rule is simple: perfection or nothing. It will only give you a yes output if every single one of its inputs is also a yes. If even one input is a no, the whole thing is a no. All or nothing. And its truth table makes this crystal clear. Look at that! Unlike the OR gate that was full of yeses, there is only one single scenario where the AND gate gives a yes, and that's when both A and B are on. Anything less results in a flat no. Because of this strict all-or-nothing nature, the AND gate is seen as performing a multiplication operation. Anything multiplied by 0 is 0. In its Boolean expression, this is written as A times B equals Z. All right, our final basic gate is the simplest of them all, but you could argue it's the most powerful. Let's meet the NOT gate, also known as the inverter, or as I like to call it, the rebel. The NOT gate does exactly what its name suggests. It takes one input and just flips it to its complete opposite. It's a total rebel. If you give it a yes, it says no. If you give it a no, it says yes. And its truth table? Oh, it's the shortest and sweetest of them all. If the input is 0, the output is 1. If the input is 1, the output is 0. Simple, direct, and incredibly useful. This gate is so unique it gets its own special look. That little bubble you see in its symbol, that means inversion. And in its written expression, we put a little bar over the letter to show that the output is always its opposite. So there we have it, our complete toolkit: the agreeable OR, the strict AND, and the rebellious NOT. But how did these three super simple decision makers combine to create something as mind-blowingly complex as a smartphone? This is where the real genius is. You see, the output from one gate can become the input for the next one. And by linking them up in these massive, complex chains, an OR seeding into an AND, whose result then gets flipped by a NOT, engineers create these vast logic networks. And these networks can perform tasks that are way more complex than any single gate ever could on its own. It's just like our source material puts it so perfectly. Combining these simple gates is what allows us to perform incredibly complicated functions. From adding two tiny numbers to rendering a whole video game, it all starts right here. And that is the key thing to remember. It is truly amazing when you think about it. Our entire digital civilization, every app, every website, all the software we use every day, is built on these three fundamental, almost childishly simple, logical rules. It really makes you wonder, doesn't it? If the entire digital world can grow from just three simple rules, what other elegant, simple principles might be hiding just beneath the surface of our own complex universe? Something to think about. Thank you so much for joining me today on Cognito Key. Hopefully you have a new appreciation for the silent, lightning-fast thinking that's happening inside your devices right now. If you enjoyed this breakdown, please do like, share, and subscribe for more explainers just like this one. See you in the next one.